Alright, so let's do the polynomial functions notes. Make sure to put your information up here so you don't forget. So we talked about adding, subtracting, and multiplying polynomials so far, and dividing by monomials. So we're going to talk about how they work as functions now. And remember, a function is something you put a number in and you get a number out. Like this right here, you could put a number in for x and calculate what it equals. So that's a polynomial. It would be a function. All polynomials are functions. And we're just going to go over some of the basics here, and then next time we're going to get really into the details of how graphing polynomial functions works and how you can tell from an equation what the graph will look like. So anyway, start off, a polynomial is written in standard form. It's a lot easier to deal with them when they're in standard form. That means the exponents are in descending order. Descending meaning biggest to smallest. So this one right here, the largest exponent is 5, x to the 5th there. So that's the one that is going to be written first. Negative 3x to the 5th. So the 5 goes first because it's the biggest exponent. Then the next biggest, we have x to the 2nd, x to the 1st, and x to the 3rd, and just a constant term. So the 3rd is the next biggest, so put 2x to the 3rd. Then get x squared is the next biggest. X to the 1st is the next 2x, which is actually x to the 1st, and the constant term will go at the end. So we just rewrite that biggest power down to the smallest, the constant term. Sorry, you couldn't see the last part for a second. So, biggest power to the smallest, all in order. All right, now the the blank is the coefficient on the blank term. The leading coefficient. And you might be wondering, what is a coefficient? Well, in this one up here, the negative 3 is a coefficient, the 2 is a coefficient, the 5 is a coefficient, the 2 is a coefficient. It's the number multiplying the variable part in each term. So it's the leading coefficient is the one on the first term, or you could also say the leading term. So this one up here would be the negative 3. This one down here, this one, first we'll check that it's written in standard form, biggest power to smallest. Yep, so just circle that first coefficient there, the 8. Okay. Number 3, the blank of a polynomial is the value of the blank exponent. Degree. The degree of the polynomial is the value of the greatest exponent. So the greatest exponent in here is the 3rd power. So this would be 3rd degree, or degree 3 polynomial. Okay, next one. The blank of a polynomial is what happens to the blank values as x goes. So that's what happens to the x values as x goes. The end behavior of a polynomial is what happens to the x values to the y values as x goes that way or that way. We'll be more precise about this next time. So it's what happens to the y values, sorry about that, as x goes really big or really small on the graph. So on this guy right here, you can tell when x, this is the x-axis, right? And this is the y-axis. So when x is going really big, the function is getting bigger and bigger and bigger, and it's going to go up, 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 up. So up to the right. But what about when x is going in the negative direction, that way? The function's going down. So you can say down to the left. We'll talk about some more precise ways of talking about this next time. But end behavior, it's what happens to the y. The y is up and down. So when it goes to the right, does it go up or does it go down at the end? When it goes to the left, does it go up or down at the end? Okay. Now, next page. This first one, going to say zeros are values of x that make y equal 0. So if you plug those numbers into the equation, it'll make the polynomial equal 0. And on the graph, they can be easily found by looking where the graph crosses the x-axis. Because this is the y-axis. Y is positive up here, it's negative down here, and y equals 0 when you're on the x-axis. So on this example right here, the zeros would be right there and right there. So this one is 0, and this one looks like about 3.8. Are the zeros for this graph. Okay, and if you find it with the equation, obviously you'll get it exactly, but this you can just tell by looking on the graph about where they are. All right, last two examples. This first one, how many zeros? Well, it's 1, 2, 3. 3 zeros. And what about end behavior? Let's say on the right and on the left. On the right, this is going up. On the left, it's going down. Like I said, we'll learn another way that we can also write that next time. And this graph is crossing the x-axis 2 times, it looks like. So that would mean 2 zeros. And up left, down right.